In this lesson, we're going to learn that angles can be measured in not just degrees, but they can also be measured in what we call radians. This is very similar to temperature. We measure our temperature in degrees Fahrenheit, but a lot of other countries measure their temperature in degrees Celsius. So radians is just another way to measure angles as opposed to the degree measures that we've always known. So before we get started looking at how to measure an angle in radians, let's just revisit measuring angles in degrees. So in this upper left-hand circle here, we'll call this our degree circle. Let's remind ourselves that in standard position, when we have a ray on the positive x-axis, that if we move counterclockwise, we're measuring out positive degree angles, that we know that if we were to rotate the positive x-axis up to the positive y-axis, this would be called 90 degrees. Now within this quadrant right here, quadrant 1, of course we can break down 90 degrees. If we wanted to just go halfway in this quadrant, we could call this 45 degrees. If I wanted to take quadrant 1 and divide it into 3 equal parts, I would have a 30-degree angle here, and maybe a 60-degree angle here, and then the remainder would get us up to 90 degrees. Now this doesn't look very good as far as to scale, but hopefully you have the idea. If this is 90 degrees, if we continue, then over here on the negative x-axis, we call this angle 180 degrees, add another 90, we're at 270 degrees, add another 90, and we're up here at 360 degrees, one complete rotation. This is also 0 degrees here if we haven't rotated our positive x-axis in either direction. A reminder, we can also take the positive x-axis and we can rotate down clockwise and around, and those would give us negative degreed angles. So a reminder, what if I started on the positive x-axis and I went down clockwise? Well, then I could call this negative 90 degrees. Remember that these two angles right here are coterminal. They name the same ending place. If I were to continue clockwise, then I can also call 180 degrees negative 180 degrees. Okay, those two are coterminal. If I went another 90 degrees up here, I can say that 90 degrees is coterminal with negative 270 degrees. Another 90 down here, I can also call this negative 360 degrees. So those are coterminal, just as a reminder. And then within each quadrant, we can break it down further if we wanted to and get other degreed angles here. All right, this is our degree circle. This is going to be our radian circle. All right, so the idea of a radian circle, let me see, I needed a little piece of floss here to measure off. Let's see if I can get that. I'm going to take a little piece of floss and I'm going to measure the radius length of this circle. So I'm going to measure it from the origin over here to the edge of the circumference of the circle, and I'm going to cut that little piece off there. Now, of course, this isn't real precise, but hopefully it'll do the job. Not precise at all. I'm not attending to precision. Let me see if I can get that to cut. Well, I didn't think I'd have this much trouble. There we go. Okay, let's say that I take this little piece of dental floss here and I measure off to match the radius length of this circle. Then let's say I take this little piece of floss, it's probably hard to see, and what I want to do is I want to form it. I want to start over here on the intercepted arc over here. This is part of the circumference, and I want to bend it so that it matches the circumference of the circle, and then where the dental floss ends, I'm about right here. Now I know you're not able to do this, but if you were to measure off a piece of dental floss here, or maybe you can do it if you have your own dental floss, you should end up about right there. What we just did is we matched the radius length to an intercepted, that just means I found a piece of this entire arc or circumference. So this distance right here matches the radius length right here. And if I were to kind of draw in this little dashed line here, what we say is when the radius length matches this distance on the circumference of the circle, that this measure is 1 radian. So how does 1 radian compare in degrees? Well, to me, this looks like it's less than 90, but more than 45 degrees. If I had to estimate, I would say that 1 radian is about equivalent to about 60 degrees. All right, what if we were to continue that pattern, take our same piece of dental floss and where I ended up here, attached it, matched it to the circumference. Where does it end this time? Well into quadrant 2. The end of my dental floss is about right here. So if I draw on this dashed line, I can then again say that this angle measure right up here is 1 radian as well. So from standard position, now I not just have 1 radian, but if I chose both these sections, this angle measure right here would be 2 rads, or 2 radians. So 1 radian, and then 2 radians, and we can continue this pattern counterclockwise. Notice what happens is you'd want to say that that dental floss is going to actually get down to the negative x-axis, but it's just a little bit shy. The third piece of dental floss ends about right there. So from standard position, I've got another section or another radian. So I would say that this is 3 radians. So we want to be as comfortable with radians as we are with degrees. So if someone said, think of an angle whose measure is 2 radians, not 2 degrees, we would want to kind of think about the dental floss kind of, matching up on the circumference, that 2 radians is more than 90, but less than 180 degrees. And it's just slightly more than, well, I would say slightly more than 90, but it's not quite halfway into this quadrant. So I would guess that if I'm saying that 1 radian is about 60, 2 radians is about 120 degrees. 3 radians would be about 180 degrees, but it must be smaller than 180 degrees because that third little tick mark right there doesn't come all the way down to what we know as 180 degrees. Well, I can continue this into quadrants 3 and 4. So let's match up the end of my dental floss with where I left off last time. Kind of mark off that little tick mark there. This would be 4 radians. Let's keep going. So how many complete radians are there in 360 degrees? Well, it looks like I'm about right here. That's 5 radians. Right, match up the dental floss again, and what happens is, again, I fall short of that positive x-axis. So there's a little more than 6 whole radians in a complete rotation of 360 degrees. So this is your first look at radians. I know it's a little bit different. Okay, so I can say 1 radian, if this is 1 radian right here, as far as the angle measure is concerned, I would say that's about 60 degrees. It's probably smaller. So actually, I might even say, you know what, let me not go 60, because 3 radians is clearly not 180. Maybe I'd say it's about 59 or 58 degrees, something like that. But if I'm ever going to estimate, then I'm always going to bump that 58 up to 60 in some of my work. And we'll revisit that a little bit later. All right, so what if we said we had an angle whose measure was 1.5 radians? Well, 1.5 falls between 1 and 2, so maybe 1.5 radians might actually be up here at 90 degrees. What about an angle whose measure is 2.75 radians? Well, I know 2.75 is closer to 3 than it is to 2, so 2.75 radian would be about right here in quadrant 2. So we can kind of estimate as well in the radian system. Okay, another thing to think about is that we can have also negative radians. So instead of my going around clockwise or counterclockwise, what if I went around clockwise? So if I started up here at the positive x-axis, instead of going up and around, I went down and around. I can see that negative 1 radian would fall about right here. Then negative 2 radians would be another dental floss piece. So negative 2 radians would be about here. Negative 3 radians would probably be about right here. Negative 3 rads, that's kind of what we write. If we don't write rad, then we just don't write anything, and we don't have a degree on that. We just say negative 3 with or without the rads. All right, so we can continue. So we could probably come all the way over to here and say, well, if I go in a clockwise direction, this angle right here from the positive x-axis all the way around would probably be negative 6 rads. All right, so we're going to come down here before we go to this big circle and what I want to do with it, and we're going to define what a radian is. So 1 radian is the angle created when the intercepted arc length, and here we're talking about the circumference, when the intercepted arc length equals the radius. So let's go back up here. Here's the radius. We use the dental floss that matched the radius length. So when we stopped right here and put that tick mark and we drew back over here to the origin, this angle measure that's created is called 1 radian. All right, let's extend a little bit with radians. So I'm going to call this our unit circle. Now, unit just means length of 1. So unit meaning the word 1. So what we want to think about is that this radius length right here just has a measure of 1 unit. Whatever that unit is, this is just going to be called 1. 1 inch, 1 centimeter, 1 mile, whatever, just 1 unit. All right, what if we wanted to know what the circumference was of this unit circle? Well, we've got a formula. The circumference of a circle is 2 pi r. So in our case, our radius length is just 1 unit, whatever it is. So for me, the circumference is going to be a measure of 2 pi. Remember, pi is about 3.14. So the entire circumference length all the way around is 2 pi. Remember, 2 pi is about 6.28, I guess. So if I didn't go all the way around and I'm only considering the top half of the circle and its intercepted arc length, if you will, I would say that if I started on the positive x-axis and ended up over here, that this distance right here would be half of 2 pi, or just pi. Remember, pi is about 3.14. So what's this arc length from the positive x-axis up here to the positive y-axis? Well, if this is 1 pi, then this distance right here would have to be pi over 2. So we're talking in terms of pi. So if you found a decimal for that and took 3.14 and divided it by 2, if you took 3.14 and divided by 2, you'd get approximately 1.57. All right, so now we know that this distance is about 1.57, or pi over 2. This distance is pi. We know all the way over here it is 2 pi. So what is this distance? Well, that's another pi over 2 section, because this is pi over 2. So this is 1 pi and 2 pi. So halfway between 1 and 2 is 1.5. So instead of calling it 1.5 pi, we typically change 1.5 to the fraction 3/2, which is 1.5. So we'd call this 3 pi over 2. So I'll usually put the pi on top with the 3 instead of out to the side there, so it doesn't get confused to be in the denominator. If you found a decimal equivalent for 3 pi over 2, you did it on your calculator, I think you're going to get about 4.7. I guess I should do that real quick. Let me see, 3 pi over 2. Yeah, 4.71. So that's approximately 4.71. All right, so we should kind of see some similarities with our decimal numbers and what was going on up here. Remember, this was 1 radian, 2 radians. Halfway between 1 and 2 would be 1.5. And 1.57 is exactly, well, approximately close enough. 1.7 is pi over 2. So I can call this angle measure right on the positive y-axis pi over 2, which is approximately 1.57, which makes sense between 1 and 2. All right, so then we look over here, this intercepted arc length, this arc length right here that matches this angle measure, this intercepted arc length of pi would actually mean that this angle measure is exactly pi. So now I'm going, oh, okay. Well, I guess pi as a distance is 3.14, but now I'm starting to see that 180 degrees is equivalent to pi radians. Just like 90 degrees up here is equivalent to pi over 2 radians. All right, 270 degrees up here is equivalent to 3 pi over 2 radians. Interesting. Okay, and we're going to explore more about this unit circle in some later lessons. But right now we're talking about radians with just numbers. Notice I have no pi's here. I didn't do anything with pi's here. But also radians can be measured in terms of what we call pi as well, if we want to get exactly on these axes right here. So again, we'll have more work to do with this. All right, something that we're going to also be working with in the future are what we call conversions. How do we convert from radians to degrees and vice versa? Well, it all starts with knowing that pi over 2 radians, you don't have to put that little abbreviation radians, but pi over 2 radians is equal to 90 degrees. So if I multiply both sides of this equation by 2, then I know that pi radians is equal to 180 degrees. Okay, likewise, we know that 3 pi over 2 radians is equal to 270 degrees. Oops, I don't think y'all can see that, so sorry. So for our conversions, we do know these to be true based on our work with this unit circle up here. And in our future work that's going to come up, we're mostly going to use this relationship right here to help us convert from degrees to radians and then vice versa. Okay. All right. Hopefully not too confused yet, but let's go ahead and continue. All right, on the back of this page, I see 2 circles. One we're going to call the pi over 6 circle and one we're going to call the pi over 4 circle. These are 2 circles that we're charged with memorizing. We won't be memorizing a pi over 7 circle, a pi over 5 circle, pi over 9 circle, just pi over 6 and pi over 4. Okay, so what are we supposed to do with these circles? Well, I want to create, for pi over 6, I want to create a pi over 6 circle. That is, I want to section off pi, which remember, all the way around is 2 pi. So pi is just the top half of the circle. I want to take pi and divide it into, top half of the circle, 6 equal sections. Well, 6 equal sections mean that I'm going to have 3 equal sections in quadrant 2 and 3 equal sections in quadrant 1. So I'm going to go ahead and mark off those little tick marks, best I can, eyeballing it. So I see that from here to up here, this first tick mark, that's 1 section. The distance between here should be 2 sections, and the distance that concludes from this tick mark to the positive y-axis should be our 3rd section. So 4 if I did continue, and then 5 right here. So let's dash in some lines here. I just took pi and divided it into 6 equal sections, not 2 pi, because 2 pi would be all the way around. Now I can take the bottom half, this pi down here, and divide it also into 6 equal sections. All right, what we're going to do is we're going to go around and label each of these sections. Starting from the positive x-axis, if I have one section add a 6 on the top half of this semicircle here, the top half of this circle, this semicircle, this is called pi over 6. 1 pi over 6 section. So this angle measures pi over 6 radians. And I know from my work with degrees that if this quadrant is 90 degrees and I divide it into 3 equal parts, that this would be 30 degrees. So we want to build some relationships. So a pi over 6 radian is equal to 30 degrees. All right, let's go up and pick up another pi over 6. Well, 1 pi over 6 plus another pi over 6 is 2 pi over 6, but that fraction requires reducing, so we're going to say pi over 3. Well, I know in degrees that that's going to be 60 degrees, so pi over 3 radians is actually equal to 60 degrees. Notice that pi over 3 is 2 pi over 6 sections. All right, let's continue. This would be 3 pi over 6. Well, I don't want to write 3 pi over 6. I know 3 pi over 6 reduces to pi over 2 radians. I'm not going to write radians this time. I don't have to. And I know pi over 2 is equal to 90 degrees. So pi over 2 radians is 90 degrees. Okay, let's continue from the positive x-axis. Let's pick up our 4th pi over 6 sections. So you know 4 pi over 6 is going to reduce to 2 pi over 3. We could put radians there. We don't have to. Without the word radians, we understand that to be radians. That's picking up another 30-degree section. That's equal to 120 degrees. And that makes sense. Let's pick up another pi over 6 section. So now that's 5 total. So this is 5 pi over 6, which doesn't reduce radians. You can write radians or not. Pick up another 30 degrees. That's equivalent to 150 degrees. So the degree symbol is important to write, but the radians is not. Without the degree symbol, it's understood that this angle measure in terms of pi is in radians. All right, pick up another pi over 6 section. That's going to bring us to 6 pi over 6, but we're not going to write 6 pi over 6. We're just going to write pi, which equals 180 degrees. You can continue all the way around the circle until you end up at 360. So this is 7 pi over 6, 8 pi over 6, which reduces to 4 pi over 3, 9 pi over 6, 9 over 6 reduces to 3 halves, 10 pi over 6, which is 5 pi over 3, 11 pi over 6, it doesn't reduce. Again, you can put radians in front of all of these angle measures in terms of pi. You can put radians, but you don't have to. But if you're going to show its equivalent degree measure, you have to put the degree. So 210 degrees, because you're picking up 30 degrees all the way through each of these sections. 240. This is 270 as we know it. This is 300 degrees. This is 330. 12 pi over 6 would reduce to 2 pi, and that's 360 degrees. Now, we went around in the positive direction, but we very well could go around in the negative direction as well. We could call this, if we went down clockwise, we could call this negative 1 pi over 6, or negative 30 degrees. We could call this second section down here, this angle negative 2 pi over 6, or negative pi over 3, or negative 60 degrees, etc. All right, let's break down the pi over 4 circle. Same idea, but take pi, the top half of the circle, and divide it into 4 equal sections. Well, that's pretty easy. So we'd call this 1 pi over 4 section, or pi over 4 rads. We know that's equivalent to 45 degrees because that's half of 90. Pick up another pi over 4, so that's 2 pi over 4. But we're not going to leave it as that. We're going to reduce it to pi over 2, which that makes sense. Positive y-axis will always be pi over 2. All right, pick up another pi over 4 section. That's 3 pi over 4. 3/4 doesn't reduce. Add 45, because that's half of 90 to 90, and we get 135 degrees. 4 pi over 4. We're not going to write 4 pi over 4. That's just going to say pi. Add 45 to 135, and we get 180. Let's go ahead and divide up these last 2 quadrants also into 2 equal sections. So this would be 5 pi over 4. This is 6 pi over 4, but 6 over 4 reduces to 3 over 2. This is 7, count them, 1, 2, 3, 4, 5, 6, 7 pi over 4, and then 8 pi over 4. And 8 over 4 is 2 pi. All right, take 180, add 45. This is 225 degrees. Add 45 to this number, that's 270. This is 315. And this is 360. So what we have to do, our responsibility, is to memorize the pi over 6 and the pi over 4 circle and be able to locate different angles on those circles. All right, so let's go ahead and determine the quadrant in which each angle lies. Notice that we have no degree measures here, so we're talking about in terms of radians. Whether or not that's with their pi or not is determined by if there's a pi in the question. Well, I can see that these problems 5, 6, and 7, and 9, I don't have pi's. So remember, we might want to think back to maybe this circle right here to help us locate the quadrant where that angle lies. All right, 5 pi over 6. Determine the quadrant in which each angle lies. 5 pi over 6. I first look at the denominator and go, oh, that's the pi over 6 circle. That's 5 out of 6 sections, 5 over 6 of the pi over 6 circle. Well, I know this is 1, 2, 3, 4, 5 pi over 6. I'm in quadrant 2. Negative 5 pi over 3. Well, I know negative means I'm going to have to go down from the positive x-axis. I don't want to use the pi over 4 circle. I don't have a pi over 3 circle, but that's okay. What I can do here is I can double the top and double the bottom. I can make the 3 a 6 by doubling, multiplying by 2 over 2. Then I know I'm dealing with the pi over 6 circle, and I have negative 10 sections that I want to count off. So if I go and start from the positive x-axis, I can count negative 10 pi over 6. So negative 1, 2, 3, 4, 5, 6, 7, 8, 9. The 10th pi over 6 section would put me right here, coterminal with pi over 3. I'm in quadrant 1. All right, look at example 3. I look at I notice I have a negative angle measure, and I notice the denominator is 12. I don't have a pi over 12 circle. So then I think, okay, well, I can't double 12 or multiply it by anything to get a 6 or a 4. So then I start thinking about, what if I did have a pi over 12 circle? Well, pi over 12 would mean that I'd have to take each of these individual sections and divide them in half, so that I would have 2, 4, 6, 8, 10, 12 pi over 12 sections on top here. So then I'm looking at this going, okay, it's negative though. So I got to go down this way. So this is negative 2 pi over 12, because that's negative pi over 6. Negative, if I divide these sections in half, remember that's a pi over 12, a 2 pi over 12, 3 pi over 12, 4 pi over 12. Negative 5 pi over 12 would put me down here halfway between these two angles. I'm in quadrant 4. I know that's kind of weird. Another way to look at it is this way. Just focus on the numbers. 5 is not quite 6. If 5 were 6, then that would be a half. 6 over 12 being a half, and that would be negative a half pi, which would be down here. But I'm not quite there, so I'd stop short. And at least it'll get you into the quadrant to answer this question. Okay, 3 pi over 4. Well, we can read that directly from the pi over 4 circle. 3 pi over 4 is in quadrant 2. Okay, let me go ahead and finish problems 8 and 10, since they're also in terms of pi, before I transition to angles that are in radians but not in terms of pi. Hang in there, we're almost done. All right, a negative 11 pi over 6. Oh, thank goodness, that's the pi over 6 circle. But I'm going negative, and I want negative 11 of these pi over 6 sections. So negative 11 would mean I need all but one of these pi over 6 sections. So negative 11 pi over 6 would be coterminal with pi over 6. I'm in quadrant 1. Okay, let's look at this last one here in terms of pi. I don't have a pi over 3 circle, but I can double and make the 3 a 6 and double the 2 and make it a 4. So let me count off negative 4 pi over 6 sections. So negative 1, 2, 3, negative 4 pi over 6 sections, which is coterminal with 4 pi over 3. I'm in quadrant 3. All right, if you are comfortable and you feel like you want to answer these other problems, or any of these at any time, just pause the video and then fast forward it when you turn it back on to make sure that we're matching up. All right, -1. This is not degrees, this is radians. If it was degrees, it'd be a degree symbol on it. -1 radians. So turn your dial in your brain to radians. -1 radian. Well, it's not in terms of pi. Remember, -1 radian would mean go down, and -1 radian is about 60 degrees, a little shy. So I'm in quadrant 4. All right, -3.5 radians, okay. Well, again, I can use either one of these circles. -3.14 radians would be all the way over to here, the negative x-axis, -3.14, but I need a little more than -3.14, so I'm slightly above the negative x-axis. I'm in quadrant 2. All right, problem 7. What quadrant would have an angle whose measure is 7 radians? Okay, 7 radians. Again, remember, we can always use this circle right here. Well, all the way around is 6.28 radians, but I need to go a little bit past to get to 7 radians, so that means I'm going to land in quadrant 1. All right, 2.2, a little more than 2 radians. Well, here's 2 radians. This is 3 radians. 2 1/4 would be about right there, so I'm in quadrant 2. Okay, noticing the time too, and just thinking about the upload and everything, looking at this last objective. Okay, I'm going to do 1 or 2 examples and then have you guys finish the rest, and then we'll check the key the next time we see each other. Sketch each angle in standard position. All right, standard position, coordinate plane, always start positive x-axis. Hopefully by now we know that 3 pi over 2 would be 3 pi over 2 sections. So this is 1 pi over 2 section, another pi over 2 section, and the third pi over 2 section. So if I draw a little arrow, show this where you're stopping, make sure and darken in your terminal ray and your initial ray, and showing the direction in which you're traveling. Okay, 4 pi over 3. Okay, well, I think of that as doubling 4 and 3 and getting 8 pi over 6 sections. So my brain goes straight to the pi over 6. 8 pi over 6 sections. Well, I know there's 6 of them up here, pi over 6 sections, so I need 2 more to make it 8 pi over 6. 4 pi over 3 is right down here, closer to the negative y-axis than it is to the negative x-axis. So I'm thinking, okay, 10 pi over 6. Well, that's 6. Oh, excuse me, 8 pi over 6. That's 6, and I need 2 more pi over 6 sections. I'm a little more than halfway down through this quadrant, and I want to make sure my terminal ray is a little more than halfway beyond the negative x-axis. So darken in the terminal ray, the initial ray, show the direction you're traveling with this little swirl. Okay? All right, so you guys go ahead and try the remainders. And again, like I said, the remaining problems, and then next time we see each other, we'll check with the key and have any discussions that we need to.